In today's lesson, we will try to set out a stair. This is a real live job. So what we are going to do here is to try and set out these two flights. The architect virtually gives all the set outs. We also have a set of survey plans which show some dimensions, and the CAD files are there. Now, whether we have the dimensions we require to set out the stair, that we have to check. The first thing to do is identify the drawings which you require to detail this. So we are going to detail only one flight. So you, from the set of drawings, have to identify that drawing. Next thing to do is to check whether the architect has set it out as per Australian standards. You cannot go and detail a stair when the architect has set it out outside the Australian standards. So it is a pre-requirement that you understand the Australian standards before you can detail any stair. There are two Australian standards with deal with stairs. One is AS 1428, which is for public access. That means for all those buildings where public will come and use. The other one is AS 1657, which is the maintenance standard, where public are not expected to use that stair. It is for private use or for maintenance staff to access areas. You need to know both the standards pretty good to detail the relevant stair. First thing to know, hence, is under what code does the stair fall. Different standards, somewhat different requirements. This particular stair falls under 1428 because this stair is used by public. It's not a maintenance stair. So most of the time this is dealing with the stair widths, the rise, the going, the handrail height, the gap between the handrail and the wall, the slope of the stairs, and whether stairs are widening or narrowing as you come down. There are requirements there. There are also requirements about stair overlap. They are different for 1657 and 1428. A lot of things are common, but some things are different. If you head to our website tekla.com.au and look at the Australian standards, there's a free test which you can take. You have to register yourself and then take the test. I'll also try to put this as a Google quiz so that you don't need to register or anything. You can take the test anytime and how many hour time you want to take it. Next thing you should do is to identify what are the construction requirements, or how easy or how difficult it is to construct the stair as designed, because a lot of times the engineer or the architect does not give the details as required by the fabricator, or it may have given some detail which is very difficult to fabricate. So that you have to study. You must have an understanding of what is possible to manufacture, how the fabricator makes things. Once you know that, you can then identify issues and then suggest solutions. So before you start detailing any stair, first check the drawings against Australian standards. Check the design details and see whether things can be built. Raise questions if it cannot be or it is difficult to build. That is the start point. The Tekla part itself Tekla is only a tool. Remember that. It will only help you to do what you know about things. If you don't know, whatever you build with your Tekla is going to be completely wrong. For this particular job, we are given a IFC model. Now you can't use the IFC model for detailing. You can only have a look and get an idea, okay, this is how they intend to put the stair or how set out the stair. It's only an idea. You can't use it. You can't use it for set out because it will be wrong. For this exercise, we are going to detail these two flights, that is from level 6 to level 7 stairs. The first thing to check is whether the risers and the going are within Australian standards. So Here we have 23 risers at 170 millimeters, and here it says from here to here 4500, 15 into 300 threads, 16 into 170 risers. So the total rise is 3900 over 23 risers at 170 millimeters. And then when you go into these details, it is saying, okay, 16 risers at 170, and then the little from mid landing, it is 7 risers at 170. Stick that into an Excel sheet, and you can see that there is a difference of 10 millimeters. That is a question. Well, the drawing from landing to landing is 3900, so we might have to adjust these risers a little bit to get 3900. So our risers are going to be 169.56, not 170. Even though the architect has mentioned 170, he has rounded it off. This is going to be our actual riser. Next, we have to check the going. So 4500 for 16 risers. So stick all that value into an Excel sheet. So 16 risers over nosing to nosing 4500 gives a going of 300 from up to mid landing. Then 7 risers from mid landing to first landing gives 1800. So that going is also 300. So we got equal going between up to mid landing and then from mid landing. This is the equal rise from ground to mid landing and mid landing to first floor. So they are so far okay. So we have got most of the stair standards of AS 1428 and 1657 in tidbits on our site. You can search by putting into Google site tek1.com.au and AS 1428, and you will get all these results coming up. There are a few more requirements like this, what you can see here: stair construction and how much is the space required, nosing profiles, etc., which is basically available by searching our website. All these information is available in tidbits, not like a book view. Some of the other requirements are the handrail heights, how much the handrail should go after the first nosing, say 1 tread width. So handrail must extend 300 at the top and the bottom. And then there are all these other requirements about the handrails. The handrail profile itself has some requirements you can see here on this. Certain other requirements about the handrails, height requirements, width requirements, then this angle requirement. The other thing to note about is this calculation, which is 2R plus G, should be maximum 700 and minimum 550. So let's calculate that one now. So that's 640. It is between these requirements, so that is okay. The other thing to check is the width of the stairs, the clear width of the stairs between handrails. So it is 1400 on the upper flight, and on the lower flight again it's 1400. You don't want the lower flight to be narrower than the upper flight. It is a requirement. Since the initial checks are completed, let's go about setting out the stair grids. So we have the stair running between RL 29.6 and 33.51. That is finish floor to finish floor. That's what you should be using to set out the nosing points. The structure itself might go somewhere else. That is, the base plates and all the stringers might go somewhere else, but you are going to set the grids between nosing point to nosing point. That's extremely important. Now it is also between grid 10 and 11, and we have the dimension here which is given here. Now we have a site survey for this stair penetrations which is between grid 10 and 11, but grid B is not marked, but there's a line here. We will take it as grid B and send an RFI about it, and we will use the CAD file to set out this penetration from the grid. Now checking the CAD file, I have got two RLs here, and this doesn't look like a site survey. It looks like they have brought in the architect's file and not really a site survey, so that becomes a question by itself. Where is the penetration in relation to the grid lines? We have to question that. I'm going to use the architect's value and the CAD values from here now. Alright, if I switch off some of the layers, I get one more line work here which says area boundary. So if I select that, say structure and area boundary, so I can possibly use that one. Okay, checking the CAD file further, I get some dimensions from the grid lines. I'm going to use that. I'm not going to bring this as a reference model. I'm just going to model this slab up. So between grid lines, the sum of all this between grid line and 10, which is 8,400. And I think this is the grid A and this is grid B, so I'm going to put that as grid A and B. So that is 1020. About RLs, the level 7 is FFL 33.51 and level 6A is 3900 less. So if I set Z origin at that RL, I can add 3900 and get L7. To label the Z coordinate, I'm going to use this value rather than these names. Okay, so we have set up the grids along x-axis, y-axis, and z-axis. Labels are 10, 11, AB, and these are the RL values. The Z offset origin is set at 29610. So I'm going to modify. The grid will disappear from here, and I'll have to reopen a view at Z origin. Okay. Now if I press enter here, the grid will disappear from the view, because then I will have to open a view at that RL. I'll just copy this value first and then hit enter, and of course the grid has disappeared. I'm going to create a view at that RL, which I copied the value anyway. So create view, and I get this view. First thing I'm going to do is I'm going to save this view as plan. So double click this view, and I'm going to save this as plan. Modify, apply, save. Okay. I press Ctrl I to bring this dialog box, and I have the plan view here. And if I go in here, I don't need this view anymore, so I'm going to delete it. Okay, I got the plan view. Now check the grid dimensions so that they are correct. So go to Edit, Measure, Distance, 8,400, 10,200. Open a view perpendicular to this. A view using 2 points, and then I select these 2 points. Here is a view, Ctrl P. So these are the labels. That should be 3,900. So edit and measure. $3,900. Now we want to check whether this RL value and this label is correct. So put 2 points on that, and I go to my toolbar and inquire object, which is inquire. So it comes up with this value 2610, which is correct. And let's check the other one, which is this one, inquire 36510. That's all correct. So the grid is good. The next thing I want to do is I want to create a slab opening at the at level 7 with these dimensions. The next thing I want to do is I want to create a slab opening at level 7 with these dimensions. Okay, so with the given drawings and the CAD files and the site measure, I have set out these slabs, put this slab opening here. The next thing to know is where does our nosing point start from in relation to the grid line. So along the x-axis we have 300 here. Okay, to set the stair out along the y-axis, I don't have a lot of information. So what I'm going to do here is I am going to place the stair in center line with the void opening. So I'm going to use these dimensions to set out the center lines. So I am going to set the stair using these dimensions along the x direction. So we have the grid line, and then 4744 to here to the center of the post, come back here 4500. That is where my first nosing line is going to be. Also, you look at the structure drawings for member schedule. So we got PF23 all around, which is a 230 PFC, and SH20C, couple of columns here. So I set these points up and measured the going and rise, and that's 169 and 300. I have to check whether this is less than 45 degrees. All right, it is less than 45 and more than 29 degrees, so that's okay. Okay, now if you look at the details of the stair on the architect's drawing, the drawing number is 5202. It shows us the buildup of the stair, which is a 6 mm P plate. On top of that, there is 30 mm of buildup. We are not so much bothered about what all these things are, but as steel detailers, we will be actually giving drawings for the steel plate, but we have to maintain the nosing point. So our steel plate is going to be 36 millimeters or 30 millimeters below the nosing point. The points we have created now is this point, but we are going to put steel here. The other thing to note here is the architect has shown these plates as sort of continuously folded, but that we can't do. It is not a good idea to do this. So you need to make this as individual tread plates. I will put a proposal for this type of a construction, so where you have this folding down, coming up and there, and then the next tread starts again. So if you look at the stair width, 1400 between handrails. The handrail is normally, for this type of handrail, you got to check the drawing. I'm not going to check it now, you check it, is about 38 millimeters, and then you require a minimum clearance of 50 millimeters. A little bit more doesn't matter, but minimum required is 50, that you have to maintain. So if it's a 38, you still need another 50. If you use a bigger diameter, still you need the 50 mm clearance from this wall. If you look at the stair detail, it gives some more information. Here is the handrail, and here is the stringer. Where you have to set the stringer is can be deducted from here. The other thing is, you look at the wall sheet, you will find out what that wall is. So this is the wall sheet SS04. Look at what that wall is, and you have to set the PFC at that distance. I don't know what is the packer, but you have to allow for all the other things here, and you need to calculate what the distance is. I don't know what it is right now. That distance you got to find out from the plan view or from the drawings. You really got to find out what that distance is. Here I am actually going to scale it, which should not be do like that. You have to use the plan view, the wall set out, the center line set out, and find out what that distance should be. I'm going to scale it anyway here.